In the race to build the most powerful AI, for the longest time, the motto has been pretty simple. Bigger is better, right? More data, more computing power, just more of everything. But what if the secret to a truly brilliant AI isn't just about raw size? What if it's actually about how well you teach it? Well, today we're diving into a story about how some really clever data engineering is starting to flip the script.
And that brings us to the big question at the heart of some incredible new research from NVIDIA. It really sets up this classic underdog story, a smaller, smarter AI model going head-to-head with an absolute giant. And let me tell you, the answer is not what you might expect. So instead of just throwing more horsepower at the problem, the team at NVIDIA took a different path. They made a bet, a big one. Their bet was that the quality and the variety of the data an AI learns from, that's what really matters, maybe even more than the sheer size of the model itself.
Now, to really get why this is such a game changer, we have to understand the problem they were trying to solve. We've got these AI agents now that can do insanely complex stuff right from a command line terminal. But here's the catch. The training methods, the data, that secret sauce behind the very best models, it's almost always a complete black box kept under lock and key.
And this whole secret sauce thing creates a massive bottleneck for everybody else. It's super hard to find or create good, diverse training tasks. It costs a ton of money and time. And since nobody's sharing what works, everyone else is just stuck in this slow, painful cycle of trial and error. It's like trying to teach a kid calculus without a textbook. Where do you even start?
And that is where NVIDIA's solution comes in. They built, and this is the most important part, they open-sourced a pipeline called Terminal Task Gen. The best way to think about it is like a cookbook, a recipe book for creating mountains of top-tier training data to teach an AI how to become a command line wizard. Okay, so what you're seeing here is basically their whole game plan. It's this really elegant two-pronged attack. You can see the two main paths here, right? One for dataset adaptation and the other for synthetic task generation. Both of them feed into this final, massive training set they call the terminal corpus. So let's break that down. First up, you've got dataset adaptation. This is all about being resourceful, taking really good classic problems that already exist and just adapting them for the terminal. That gives you huge coverage, a broad foundation. And then you have synthetic task generation. This is the creative part, inventing brand new challenges from the ground up to really zero in on specific skills. So let's look at that first strategy, adapting the classics. This is just a brilliantly efficient idea. The team literally took thousands of high-quality problems from well-known datasets in things like math and software engineering, and they just figured out a clever way to reframe them as command-line tasks. And the process itself is pretty straightforward, but it's so powerful. They start with this huge pile of prompts, clean everything up to get rid of the junk, and then they adapt the format. But here's the magic trick. They get a super powerful teacher AI to actually solve all these new tasks. The step-by-step solutions it generates, they call them trajectories, become the perfect lesson plan for the student AI. Okay, so that's part one. Now for the really creative bit, inventing anew. This is where they go beyond just recycling old problems and start making completely new ones. The way they do it is almost like a chef creating a new recipe, right? They combine these basic ingredients, what they call primitive skills, in totally new ways. And to do that, they first laid out all the fundamental building blocks. You can see some examples right here. And these are real-world practical skills. Things like crafting a security exploit, or automating system admin tasks, or digging through logs to debug code. These are the exact skills you'd want a command line expert to have.
And the process for cooking up these new tasks is just so smart. They pick a few of those skills, get an LLM to invent a new problem that mashes them together, and then package the whole thing up. But the absolute game changer is step 4. See, instead of building a new software environment for every single task, which would take forever, they use just 9 pre-built environments. That one move makes this whole system incredibly scalable. So, we've got this awesome 2-part cookbook for creating a world-class training data set. Sounds great on paper, right? But does it actually work? Well, this is where the proof is in the pudding. It's time for that David versus Goliath showdown. First, get this. Just by training on this new data set, NVIDIA's smallest model, an 8 billion parameter one, saw its performance on a key test jump by more than 5 times. That's not a small improvement. That is a massive leap forward, and it's all thanks to this curated data. But okay, here it is, the main event. Look at NVIDIA's model, Nemotron-Terminal. It's 32 billion parameters, and it scores 27.4% on the benchmark. Now, look at the model below it. That one has 480 billion parameters. It is 15 times bigger. And yet, it scored lower. The smaller model, trained with the smarter data, actually won.
And we're not just talking about a slightly better score here. In some areas, this training unlocked abilities the model literally did not have before. Look at this chart on data querying tasks. The original model scored a flat 0. Couldn't do it. At all. After training on this new data, it scored 60%. This data set isn't just making the model better, it's teaching it entirely new skills from scratch.
And if you need any more proof, just look at these scaling charts. The trend is crystal clear for both the 8 billion and 14 billion parameter models. The more of this high-quality, synthetic data you feed them, the better they get. It's that simple. Smarter data makes a smarter AI.
So, what's the big takeaway from all this? Well, it seems like we're heading into a new era for AI, an era where the focus might shift away from just building bigger and bigger models and toward the fine art, the actual craft of data engineering.
And you don't have to take my word for it. The researchers themselves put it perfectly in their paper's conclusion. High-quality, diverse trajectories are more pivotal than sheer parameter scale. In other words, it's the quality of the education that matters more than the size of the brain. And that leaves us with one last, really exciting question. This whole cookbook idea worked wonders for teaching an AI to code in the command line. So, what's next? What other incredibly complex fields could we unlock using this same approach? Imagine building these kinds of smart, targeted datasets for things like medicine, or scientific discovery, or even law. The new frontier in AI might not just be about building giants, but about writing better recipes.